if we have to know the relation between refractive index of a medium and the polarizing angle, so we have something called as Brewster's law. So what the law states is, when light is incidented at polarizing angle at the interface of a refracting medium, the refractive index of the medium is equal to the tangent of the polarizing angle. Okay, I'll repeat the law again. When light is incidented at polarizing angle at the interface of refracting medium, the refractive index of the medium is equal to the tangent of the polarizing angle. Okay, so what we have is mu is equal to tan p. Okay, so this is what we call as Brewster's law. Now, using the good old Snell's law, what we have is, see, if the light is incidenting at polarizing angle, then P will be the incident angle and let R be the refracted angle. So by using that, we have mu is equal to sin P by sin R, correct? Now, see, Brewster's law tells that mu is equal to tan P and mu is equal to sin P by sin R. So if you equate these two, we have sin P by sin R is equal to tan P, or sin P by sin R is equal to sin P by cos P, or sin R is equal to cos P, correct? Because sin P gets cancelled. Now, using trigonometric functions, so cosine can be written in terms of sine, correct? So we have sin R is equal to sine of 90 minus P, or R is equal to 90 minus P, or we get R plus P is equal to 90. It gives us a very clear picture as to what is the relation between the incident angle or the polarizing angle and the refracted angle here. So the angle between, or the sum of the angles of R and P is 90. In other words, we can say, if the incident angle and the refracted angle are complementary angles, then the reflected light will be plane polarized light. Okay, so this is how Brewster's law gives us the relation between R, P and mu. Okay, so keep this in mind. The Brewster's law, what it tells you is mu is equal to tan P, and by using Snell's law, we figured out the relation between the polarizing angle and the refracted angle, which is R plus P is equal to 90 degrees.